right, welcome to slope day 2. If you'll recall from slope day 1, slope is the rate of change between two data points. Okay, so today we're going to be analyzing some situations and we're going to be looking for things like slope. Okay, so suppose you graph the number of miles you drove on a trip. Okay, it says here distance in miles over the time it took you. So at 0 hours, you'd gone 0 miles. At 1 hour, you'd gone 60 miles. After 2 hours, you'd gone 120 miles. 3 hours, 180 miles. Okay, so that's what the graph is telling us. Let's see what the question's asking. Based on this graph, at what speed? Okay, so what is speed? Speed, right, is your distance over time. All right, so distance on this graph is being calculated on the y and time is being calculated on the x. So this is totally slope because we're looking at the change in y. How much distance did we travel over the time we traveled? Okay, so we can use our formula, right, which said that y2 minus y1 divided by x2 minus x1, or we could say the change in y divided by the change in x. Okay, whichever formula you want to use. You don't want to use a formula, you can come over and count it out. Okay, so if we're using the formula, we need points. So I'm seeing a point here and a point here because it's going through the corners of those grids. So that point is 160, and this point is 120. So my change in y was 60 to 120. My change in x was 1 to 2. So 60 minus 120 is negative 60. 1 minus 2 is negative 1. And when I divide those, I get 60. Okay, so now it said speed, which we usually have to put the rates on there. So my speed is 60 miles per hour, or simply 60 mph, because we like to write it that way. Okay, let's take another look. Logan is reading a book. He decides to keep track of the number of sentences he reads compared to the time in minutes it takes him to read. And he's made this nice little chart, and he says sentences read, and it goes from 0 to 90. And the minutes he was reading goes from 0 to 60. Okay. So let's see what they're asking us. At what rate does Logan read the book? Rate. Okay, rate is our slope because it's our rate of change. So again, we can either count, right? But this graph, we're counting from 0, so that'd be 10, 20. It's a little harder to count directly on these grids when we're not counting by ones. So I'm going to go with our formula, and I'm going to write it this way because it's shorter. Change in y over change in x. And so we went from, oh, we got to pick some points. Okay, I like this one and this one. Okay, so I just picked 2 points, and this point is 20, 30, and this point is 40, 60. So I went from 30 to 60 on my y. I went from 20 to 40 on the x. And that gives me 30 minus 60 is negative 30. 20 minus 40 is negative 20. I divide that and I get 3 over 2. Okay. So at what rate does Logan read the book? He reads 3 sentences, right, because that's my change in y. Y is sentences. And over time, so he reads 3 sentences every 2 minutes. Okay, but that's not usually how we would express a rate, right? Usually we would do it like we did with speed, 60 miles per hour, right? Okay, so what we want to do here is we want to go ahead and divide 3 by 2, and we get 1.5, okay, and we're going to write sentences, we're going to actually abbreviate sentences per minute, and that is more likely how we're going to see a rate written. Awesome. The growth in average U.S. income between 1976 and 2001 can be described by the following graph. Okay. Ooh, look, they used our little breaky thing, right? We talked about that when we were graphing Manuel and Susan's situation. All right, so they've broken the graph. So they started at 0, they counted for a while, but we've picked up at 16,000, then 17,000, 18,000, 19,000. Average income in dollars, and the years since 1976. So here they didn't do a break, so it's 0 to 5 to 10 to 15 to 20. All right, so what is the slope of this graph? Okay, we know that the slope can be found by subtracting our y's, subtracting our x's. So I'm looking along my line, and the only place I really see it going through a corner is here and here. Okay? So I know that this point is 0, 16,000. And this point is, let's see, if that's 20, that has to be 25 because we were counting by 5s. And then we were counting by 1,000, so that should be 20,000. So this point would be 25, 20,000. Okay, go on to our formula. So we went from 16,000 to 20,000. We went from 0 to 25. This was a change of 4,000. This was a change of 25. Okay. And dividing 4,000 by 25, I get positive 160 slope. Okay, so we can leave it like that, but if we refer back to this problem, it was $160 per year. That's what that actually translates to. Now they ask for slope. Slope is usually numerical, but if we put it into the terms of the problem, $160 per year. Okay. The graph below shows the relationship between the number of tons of elephant food remaining in the zoo's storage bin and the number of days since the food was last purchased. Okay, so the tons of food, number of days. All right, what are they asking us? What is the rate of change between the number of tons of food remaining and the number of days since the food was last purchased? Okay, so the number of tons versus the number of days. Right, so we look here, number of days is our x, not tons of food is on the y, so we've got y over x, tons over days. So again, this is basically slope formula here. Okay, so we can pick any 2 points. So I look here, definitely going through the corner at 0.60. And I kind of look down the line, nope, nope. Ooh, right there at 40 and 35. Sorry, no, 30, right? Because we're counting by 10s, 10, 20, 30, 40. Yes, okay. So we're counting, that would be 30. Okay, so this time we went from 60 to 30 on our horizontal, vertical, right? And we went from 0 to 40 on our x. So 60 take away 30 is 30. and 0 take away 40 is negative 40. Of course, we want to simplify that. We'll divide it out, and we get 3/4, negative 3/4 tons per day. Or we could say we have a decrease of, if we divide that and turn it into a decimal, we get 0.75 tons per day. Okay. Little different ways to write that. Okay, so now you're ready to work on Slope Day 2 worksheet.